So in this video, we're going to start discussing energy. So far, what we've done is we've discussed motion, 1D motion, 2D motion, we've discussed forces, and we're ready now to tackle physical situations from a slightly different point of view. And what we'll do is we're going to look at energy. We'll see that processes are in general nothing but energy transfer from one to another, or energy transferring from one form of energy to another form of energy. And we'll see that it's a very important concept. Now, energy itself can be very abstract in the sense that all we understand is that in the known universe, the amount of energy is fixed, and what happens is that energy, as a system evolves in time, energy flows from one form to the other. So what we'll do is we'll start with talking about work first. We'll understand work, and then we'll connect work to energy and all kinds of things. Okay. So let us first define work. Now, if I have an object lying on some surface, and let us say that I exert a force F on this object, and this force makes some angle theta with the displacement of the object. Okay, then we can define the work done by the force, and this is very important to keep in mind that I'm saying work done by the force F is defined as F times d times cosine of theta. Now, WF is obviously the work done by the force, so it's the work done by F. F is the magnitude of the force, and d is the displacement of the object, or the magnitude of the displacement, and then theta is nothing but the angle between the force and the displacement. Now, a couple things to keep in mind here. First of all, within the definition, I write it as f d cosine theta. So f here stands for magnitude of the force, and that means that you take the absolute value of the force. You only look at the numerical value of the force. Don't worry about directions here, okay? Then the displacement is the same thing. It is the magnitude of the displacement. Keep the absolute value. The angle theta is what is going to decide the sign of the work. Okay, and in the first example, you notice already that work can be positive or negative, or it can also be zero. Now, there are a few important properties to keep in mind. Okay, right from the definition of work, you notice that if an object does not move, under a force, then the work is obviously zero. Okay, so one important property is d equal to zero, then the work done by the force is equal to zero. Or in that case, we can say that the work done by all the forces acting on an object will be zero. Now, if theta is 90 degrees, which means if F and D are perpendicular with each other, okay, then the work done by the force is also equal to zero. So if F is pointing in one direction and D is in such a direction where the angle between the two is 90 degrees, then the work done by the force is also going to be zero. If you look at this example here, if you were to look at the work done by gravity on this object, if the object is moving to the right and gravity is pointing straight down, then the work done by gravity on this object would also be zero. And so would the work done by the contact force, because once again, the contact force that is pointing straight up would be perpendicular to the displacement of the object, and so the work done will be zero. Alright, so far what we know is we know work, and work is equal to FD cosine theta, and we know that F stands for magnitude of the force, and we'll always keep it positive. D stands for the magnitude of the displacement, we'll keep that positive as well, and then theta is the angle between F and D. And it's very important that as you do problems that you identify theta correctly, okay, and you have to ask where each force is acting and then you have to figure out the angle between that force and the displacement. So theta is not just any angle in the problem, it is a very specific angle, and it is an angle that each individual force makes with the displacement of the object. Okay, so in the next video, what we'll do a simple example, figure out what, how to do all these calculations to find the work done on an object by the